Okay, I've been going through the first part of ARC in the Swift book from Apple, and this is how I've analyzed it in Tinderbox, and I'm going to go through some of that now. Number one, how ARC works. So when ARC creates a new instance of a class, it allocates chunks of memory and stores information about the instance. When the instance is marked for release, ARC frees up the memory, naturally enough, when it deallocates it. So what does ARC track? It tracks properties, constants, and variables, currently referring to a class instance. As long as even one reference exists, ARC will not deallocate that class. Right? In general, when you create a reference to a class, you're making a strong reference, which indicates ownership, and it increases the reference count. Now, this works pretty much the same way it did in Objective-C at this level of conceptualization. In other words, if you have a strong reference, it's going to count as a reference to the object when deallocation calculations occur. If you have a weak reference, it's going to allow you to interact with the instance, but it's not going to affect the reference count. So you can deallocate even if a weak reference exists, where you cannot deallocate if a strong reference exists. In the ARC in action section, we just noticed a couple of Swift functions, init and dinit. Nothing particular going on there. And then we're going to discuss strong reference cycles between class instances. Now this happens, without looking at the notes here first, it happens when you have two instances which refer to each other, both of which can be nil, and both of which have strong references. So, for example, you have a person and they live in an apartment. Now, a person doesn't necessarily have to have an apartment doesn't necessarily have to have a person in it. But in this case, both of them do. So the problem here is that you can write code where an instance never gets to point of zero strong reference. So here's the scenario. You create a person that is an optional variable. Then you create an apartment, which is an optional variable. And then you have, so that means it can be nil or contain a pointer to a reference, or a reference to an instance rather. And then on each of those instances, you have an optional reference to the other class. So for example, on person, you have an optional reference to apartment. On apartment, you have an optional reference to person, right? And so we set them both to instances of each other. Now when I nil out John, that gets rid of one strong reference to the object, but John doesn't go away because a strong reference to it exists on the apartment object. Now when I nil out apartment at the local variable level, apartment still exists because John, which was not deallocated and still exists, still has a reference to apartment. And John now hasn't gone away because apartment still contains a reference to it. So in other words, both instances have survived because they contain references to each other, even though they are now no longer accessible at the local variable level. And that means that you have a memory leak, and there's no way to get rid of these instances anymore, even though they're kept alive by strong references to each other. Right? And I just list the details of this here. So here it is. If you have John and apartment 73 both defined as optional variables, and at first they're nils because they're optionals, then you assign instances, and you assign to each one their initial values, and then you assign the apartment instance here to the apartment property on John, and the John instance here to the person property on apartment. And then you set John equals nil. John will not be deallocated because apartment 73 still refers to it. The apartment object still points at John. And then so it's not deallocated. Now if you set apartment 73 to nil, apartment 73 is not deallocated either. You've simply eliminated a reference to it from the local variable. John still exists, floating out there in limbo, and still refers to it. Okay? Moving on. How to resolve a strong reference cycle between instances. There are two ways. You can either use a weak reference or you can use an unowned reference. And you do it in two different situations. In one situation, jump up here, I think where I have the for a weak reference, you've got two properties allowed to be nil, and so that you use weak. If you have one property that's allowed to be nil and one that must be not nil, you're going to use unowned. And I'm going to get into explaining that here. So for a weak reference, going back to person and apartment again, you do this when it's valid for the reference to become nil at some point. So here's what happens. When you have a weak, so you have a weak, instead of having a strong reference point from the apartment back to the person, you make it a weak reference. Now here's what happens. When you say John equals nil, then that weak reference that's pointing at John is going to be set to nil itself. And John is going to be deallocated. Right? And the reason that happens is because you said, I'm pointing at the John reference, but it doesn't mean anything in terms of deallocation. So when I set that local variable pointing to the John instance to nil, that's going to deallocate the object. Now once it deallocates the object, you've got a problem with the property on the apartment instance, right? Because either that property is going to point to an invalid reference or it's going to be set to nil. It's going to be invalid if it still points to John because John will have been deallocated. So now you set it to nil and now you've got a stable situation. Now what happens next is that when you go to apartment and you set the reference on the local variable to apartment to nil, that will deallocate the apartment instance when it didn't before because there is now no longer a John reference pointing at the apartment instance. And that does what it's intended to do. It gets rid of both the variables. Now the other thing I like to point out, the difference between owned and weak, is that you have to remember it really means strong and not strong. Weak is a way of saying it's owned and not strong. Unowned is a way of saying it's not owned and it's not strong. It's not strong that's being checked for dialog. That's specific. Now the apartment reference was owned by the local variable, and that's why you use the weak reference. Unowned means we're going to have a situation where, and the example they use in the book is a person and credit card, where a person doesn't have to have a credit card, but a credit card always has to have a person. So the person variable on the credit card instance can never be nil, right? So those are a couple of things that are indicating it has to be an unowned reference. Now here's what happens in that case. So I'm going to set up.
It's 6 o'clock.
Oh, thank you. So I'm going to know the customer is created and the credit card is created, passing in the phone, the number of the credit card and the customer. So now you have a situation where John exists and he has a strong reference to his credit card. The credit card exists and it has an unowned reference to John. Now there is no local variable pointing at that credit card. The only reference to it is the strong reference on the John instance of the object. So now I'm going to go and set John to nil. So when I set it to nil, that's going to deallocate John because there is no strong reference pointing at it. There's only the unowned reference pointing from the object. Now because the one strong reference on John to the credit card has been eliminated, that means that the credit card is going to immediately be deallocated and disappear because there is no local variable keeping it alive as there was in the situation of the person in the apartment. And that's the basic difference between owned and unowned. You use unowned when you want an instance to be automatically deallocated. You use it when it's not owned by a local variable, and you use it when it must be not nil. The reference must be not nil. It indicates a sort of database, you'd call it a deleting cascade situation, right? In the weak references, you don't necessarily want it deleted. With the weak references, you're more solving the problem of the strong reference cycle, keeping both objects alive unintentionally. You don't necessarily want that second object to go away, but you don't want it to prevent the other object, the first object, from going away because of an errant owner relationship rather. Okay, so there you go. And let's see if it says anything else interesting here. Unknown references are interesting. It's assumed always to have a value. It's not wrapped, always accessed directly. Because it's not optional, ARC can never set it to nil. Therefore, so you have to be sure when you set an unowned reference that it is in fact never nil after initialization, that there's always something in it. In fact, you can get a runtime error on a nil property on an unowned reference, and the behavior is completely predictable. The app will always crash. It is guaranteed to crash. Okay? Let's see what other goodies I have here. Weak references are always bars. They are never constants because they have to be able to have a nil in them. And unowned references are always constants because they must never be nil. I believe that's good enough for right now.